Recording in progress.
Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing statistics and more particularly, we shall be dealing with histograms. We shall begin with analytical questions. Harun has 200 letters to post. The histogram shows information about the masses, m grams of the letters. Complete the frequency table for the 200 letters. So the idea here is to be able to understand the relationship between frequency density and frequency. And the best way to model that is to use the model of width, area, and height. So the quantity given in intervals, this is always going to be the width. And the frequency is always going to be the area. And the frequency density is always going to be the height. Sometimes you will need to adapt by multiplying by a certain number, and we're going to see that as the questions progress. However, this is the general concept. So let's fill in the quantities for the height from the graph itself. So frequency density, we said, is going to be the height, or we can use it to estimate the height in a sense. So for the first bar here, we have a height of 5. So we're just going to put 5 next to h for the first one here. And then for the second one, we have a height of 8. So we're going to put 8 and so on and so forth. So for the third one, we have a height that is between 6 and 7. So you have to count the boxes, of course. So in this case, we have 1 unit from 6 to 7, and we have 5 boxes. So the ratio is 1 unit to 5 boxes. So 1 box represents 0.2 units. So therefore, each small box represents 0.2. This here is going to be 6.6. So we're going to write 6.6 in the table. And then for the 25 to 30, again, we need to estimate the height. So the height here is going to be 3.4. because it's 2 boxes, 2 small boxes above the 3. So this is going to be 3.4. And finally, from 30 to 50, the height is 1. So these are rectangles. So you should understand that the area is supposed to equal the width multiplied by the height, length times width in a sense. And here the length is represented as a height. So we need to figure out what the width is in each rectangle. So for this one, 10 minus 0 is 10. So the width is 10. For this one, the width is 10 as well. And then here the width is 5. Here the width is 5. And finally, here the width is 20. So we want to multiply the width by the height and check what the area should be. We're just going to call this maybe A dash or whatever. So, or A star or whatever. So A star is going to be the width times the height. So sometimes A star will be exactly the same as A, and sometimes there will be a ratio involved. So like A star will always be equal to A multiplied by 10 or divided by 10 or whatever. We will try and see. So anyway, width times height. So 10 times 5 gives us 50 here. And then 10 times 8 is 80. And then we have 5 times 6.6. So this is equal to 33. And then we have 5 times 3.4. This is equal to 17. And finally, we have 20 times 1, which is equal to 20. So we can see here that for their given values of area, they are exactly matching our computed values of area. And this will happen most of the time. There are just some challenging questions where they're not exactly the same, where we have to figure out the ratio. However, excuse me for that. However, in this case, we have the exact same number in both, so we can be confident enough to fill in the rest of the table using the blue values that we obtained. So here we have 80, we have 33, and we have 20. There is no ratio involved, so we just copy them exactly as they are. So 80, 33, and 20 should be the correct answers here. and they are according to the marking scheme. So we seem to be on the right track. Deborah records the number of minutes late, T, for trains arriving at the station. The histogram shows this information. Find the number of trains that Deborah recorded. So again, we have to use the width, height, area model in order to be able to figure this out. Remember, we have width and height and area. This is the interval. This is the frequency density. And this is the frequency. So this is what each quantity represents. We're going to create a table for width, height, and area. So for the first bar, it goes from 0 to halfway between 0 and 5. So even without calculating boxes or anything, this is obviously 2.5. So the width here is 2.5, which is 2.5 minus 0, basically. So we have 2.5 here. And then for the second interval, we have 5 minus 2.5, which is 2.5 as well. For the third interval, we have 10 minus 5, which is 5. For the fourth interval, we have 15 minus 10, which is 5. So this is 5 as well. And then for the last interval, we have 25 minus 15, which is 10. If you don't understand how I got these numbers, I can write the intervals for you. So for example, here it's 0 less than t less than 2.5. Here it's 2.5 less than t less than 5. For this one here, it's 5 less than t less than 10. And then for the 5 after it, it's 10 less than t less than 15. And finally, for the last one, it's 15 less than t less than 25. What we are interested in here is the actual width, not the interval. So that's why I wrote the width in the table. Now, we're going to get the height for each block or column. So for the first column, the height is right there. We need the ratio of boxes to units in order to be able to evaluate. So from 10 to 20, we have 10 boxes and 10 units. So here, one box, one small box equals 1 unit. So this is easy enough. This will be 12. And for the second bar, this is 26. The height is 26. For the third bar, it's 15. For the fourth bar, it's 10. For the fifth bar, it's only 2. So now we can record these values next to the height. So I'm just going to plug in the values I got. So this is 12. This is 26. This is 15. And then 10. And then finally 2. So we can calculate the area by simply multiplying width times height. So 2.5 times 12 would simply be 30. 2.5 times 26 would be 65. 5 times 15 is 75. 5 times 10 is 50. 10 times 2 is 20. We said that the area represents the frequency. So to get the number of trains that she recorded, you would simply have to add up all the frequencies or the areas in another sense of speaking. So we would just add up these 5 values, and this would give us the total frequency. So 30 plus 65 plus 75 plus 50 plus 20. This gives us 240. So the number of trains she recorded will be 240. Calculate the percentage of the trains recorded that arrived more than 10 minutes late. So more than 10 minutes late means we're talking about these 2 bars. So the last 2 entries. So the last 2 entries in terms of area are these 2, 50 and 20. So the percentage will be 70, which is 50 plus 20. over 240 times 100. And this is equal to 7,000 divided 240, which gives us 29.2%. Now let's check the marking scheme. So 240 is correct and 29.2 is also correct. The histogram shows the length of time that 200 cars were parked. Calculate the number of cars that were parked for 100 minutes or less. Again, we will have to create our table. So let me just write the intervals first so that things are clearer for you. We have 0 less than t less than 100, and then 100 less than t less than 150, and then 150 less than t, excuse me. So 150 less than t less than 200, 200 less than t less than 250, 250 less than t less than 300. It's a bit of a bore to write all of these, but just to clarify things for you, I'm going to write them down. So 300 less than t less than 400. We don't really need them. We're just going to use them to estimate the width. So the width will be final minus initial, of course. So for the first one, the width is 100. Here it's 50. Here it's 50 as well. 50 here as well. 50 here as well. And finally, we have 100 at the end. I'm just subtracting final minus initial to get the width of each bar. Next, we want to estimate the height of each bar. Excuse me. So the height of each bar can be estimated, of course, from the graph. This here, let's just get a ratio of boxes to units again. So from here to here, we have 5 boxes and 0.1 units. So we can create a ratio. We have a ratio of 5 boxes to 0.1 units. So 1 box is equivalent to 0.1 divided by 5, which is 0.02 units. So for example, to get the height of the first one, we add 0.1 plus 3 boxes, because it's 3 boxes above the 0.1. So that would be just 0.106. Excuse me, 0.16, not 0.106. So it's 0.06 plus 0.1, so it's 0.16 basically. And then for the second box, it's just 0.5. It's right there at the 0.5. So we're just going to write that down. For the third box, it's slightly below the 0.8, 2 boxes below. So we're going to subtract 0.8 minus 2 boxes. So minus 0.04, and that gives us 0.76. For the next bar, it's exactly at 1.1, so we don't need to do any calculations here. We just write 1.1. And then here we have 0.8. And finally, for the final bar, we are 3 boxes above the 0.2 line. So this would be 0.2 plus 0.06, which is 0.26. So the height here is 0.26. 26. So now let's write down the heights. So the heights are 0.16, 0.5, 0.76, 1.1, 0.8, and finally 0.26. Next, we want to get the area, and we get that by multiplying the width by the height. So the area will be 16, and then 50 times 0.5 is 25, and 50 times 0.76 gives us 38. 50 times 1.1 is 55. 50 times 0.8 is 40. And 100 times 0.26 gives us 26. And we said before that the area is the frequency. So to calculate the number of cars for 100 minutes or less, this would be from 0 to 100. So this would be the 16, basically. And then for more than 250 minutes, we want the percentage. So the percentage will be the number over the total number. So for more than 250, this means that we are referring to these two. So their number is 40 plus 26 divided by the total, which is basically the summation of all the values in the area row. So 16 plus 25 plus 38 plus 55 plus 40 plus 26. And after calculating all of this, we multiply, of course, by 100 to get it as a percentage. So the numerator here is 66. 40 plus 26 is 66. The denominator will be 16 plus 25 plus 38 plus 55 plus 40 plus 26, which is 200. And this is actually confirmed by the question, because we can see here that we are given that 200 cars were parked. So now we can just multiply this by 100 and we get 33%. So 16 and 33 are correct. The table shows some information about the mass m grams of 200 bananas. Complete the table. So they gave us the mass and they gave us the frequency and they want the height of the histogram column. So like we said, this is the area and this is the width. We can get the width from this, and then you want to get the height. So for the first row, the width here will be 20. And here will be 10. Here will be 5. And finally, here it will be 15. And then to get the height, we divide area by width, of course, because area is height times width. So if we divide the area by the width, we get the height. Now, let's start with the one that they actually gave us, because it might not be exactly the same as their given height. So I'm going to create H star, for example, here. And I'm going to write down what my height should be, what I expect the height to be, and then we'll see if a ratio is involved or not. So H star is area divided by width. So 40 divided by 20, this is 2. And then 70 divided by 10, so this is 7. And then we have 60 divided by 5, so this is 12. Finally, 30 divided by 15, which is 2. So it's not exactly the same. H and H star are not exactly the same. We see here that we're actually multiplying by 2, or rather, to go from this to that, we are dividing by 2. So we have to apply the same ratio to all our values. So I'm just going to divide by 2, and I'm going to put here 1. I'm going to divide by 2 here as well. So I get 3.5. And here I get 1 as well. So the answers are 1 and 3.5 and 1. And these are the correct answers. So we move on to the next question. The histogram shows the distribution of the masses, m grams of 360 apples. Use the histogram to complete the frequency table. So here we are given the intervals. We can estimate the width from the intervals. So we have here 30, 10, 10, 20, and finally 30. And we can get the heights from the histogram itself. Here we are given a key. The shaded square represents 10 apples. So 5 small boxes represent 10 units. 1 small box will represent 2 units. So here we have 9 boxes. So this is 18 units. So the height here is 18. Let me just write the scale quickly, just to help us get a better idea. So each 10 boxes are worth 20 units. So this here will be 20. And then this here will be 40, 60, 80. This helps us count easier. And finally, 100. And we know that each small box represents 2 units. So for the first one, it's 20 minus 2, which is 18. For the second one, this would be 80 minus 4, because we have 2 boxes here. So 80 minus 4 is 76. For the third one, it's 100 minus 4, so this is 96. For the fourth one, it's 40 plus 3 small boxes, so 46. And then for the final bar or column, we have 20 minus 3 boxes, so this would be 14. Now that we have the heights, we can just write them down in the table, not in the table, just next to the table. So the height here will be 18, 76, 96, 46, and 14. And then we can get our version of the area by multiplying the width by height. So 30 times 18 is 540. 10 times 76 is 760. 10 times 96 will be 960. 20 times 46 gives us 920. And finally, 30 times 42 gives us, 30 times 14, my mistake here, gives us 420. So this is our area, which is supposed to be representing the frequency. And this is the actual frequency here. And we have to figure out the ratio between them. So for our values, we have 920 corresponding to 92 and 420 corresponding to 42. So basically we are dividing by 10. So we can fill in the rest of the table quite easily. 54, 76, and 96. Let's check the marking scheme. So these are the correct answers here. The table shows information about the time, T minutes, taken for each of 150 girls to complete an essay. The information in the frequency table is shown in a histogram. The height of the block for the 60 to 65 interval is 5. Complete the table. So again, this is a conceptual question without an actual graph. Let's figure out what to do. So the intervals are the width. The frequency is the area. So we should get our own version of the height. But first we need to compute the actual width, of course. So this will be 5. This will be 5. This here will be 10. 20, and finally 50. Now, in order to get the height, we divide the area by the width. So 10 divided by 5 is 2. 26 divided by 5 is going to be 5.2. And then 34 divided by 10 is 3.4. This here will be 2.9. 58 divided by 20. And finally, 22 divided by 50 is 4.4. Now, their height is actually 5. So there is a ratio involved. So this is our height. Let's call it h star, for example. And their h starts at 5. So we have to figure out the ratio that is involved here. So we multiply by 2.5 to get 5. And we have to apply the same ratio to everything. So 5.2 times 2.5 gives us 13. And then 3.4 times 2.5 gives us 8.5. 2.9 times 2.5 gives us 7.25. Finally, 4.4 times 2.5 gives us 11. So these are the values that we should put in the table. 13, 8.5, 7.25, and 11. Let's check the marking scheme. These are the correct answers: 13, 8.5, 7.25, and 11. I seem to have made a small mistake. So let me just go back. So it's 50 divided by 22, which is, 22 divided by 50 was supposed to be 0.44. So I just made a small mistake here. This is supposed to be 0.44. So this here was supposed to be 1.1, not 11, rather 1.1. This is a small, just decimal mistake, but it's the same exact concept. So 1.1 is the correct answer here. Next, we move on to questions that require drawing. A group of 50 students estimated the mass m grams of sweets in a jar. The results are shown in the table. Complete this histogram to show the information in the table. It's pretty much the same concept. First, we want to get the width. So the width here is going to be 200, 100, and then 50, 50 again, and finally 100. This is the frequency, so this is the area, and we want to get the height. This is our version of the height, of course. So the height here is area divided by width. So 5 divided by 200 is 0.025. And 9 divided by 100 will be 0.09. 18 divided by 50 equals 0.36. 12 divided by 50, 0.24. And finally, 6 divided by 100 will be 0.06. So this is our version of the height. Now let's get the actual heights from the graph to see if there is a ratio involved or not. So first, let's get a ratio between the boxes and the units as usual. So from here to here, we have 10 boxes and we have 0.1 units. So the ratio will be 1 box. So 10 boxes first to 0.1 units. So 1 box is 0.01 units. So now that we have the information we need, 1 small box is 0.01. So the height here will be 2 boxes and a half, which is 0.025. And the height for the last column will be 1, 2, 3, 4, 5, 6. We have 6 small boxes, so this is supposed to be 0.06. So we realize that their version of the height is exactly the same as ours, 0.06 and 0.025. So we don't really need to create another column. They will be exactly the same numbers. Now we just need to plug the remaining 3 numbers, plot them onto the graph. So for the first one, we have 0.09. So 0.09 will be 9 small boxes, and it lies between 200 and 300. So the height will be, this was not very accurately drawn. Let me do it again. So this is the height of the histogram here, of this part of the histogram. So one small box below the 0.1. And then for 300 to 350, so 350 will be in the middle between 300 and 400. So 5 small boxes away. 1, 2, 3, 4, 5. So this is our 350 here. And it rises up to a height of 0.36. So where is 0.36? It's above the 0.3. And we want 6 boxes above the 0.3 because one box is 0.01. So 0.36 will be 1, 2, 3, 4, 5, 6. So this here is 0.36. So we want to rise up to a height of 0.36. There we are. And of course, we end it at 350. Excuse me, I'm doing the best I can on the screen, but it's not as accurate as one would love to have it. However, in your exam, you do have access to a ruler, so you should have a much nicer drawing than mine. And then finally, for the last bar, which lies between 350 and 400, you have a height of 0.24. So 0.24 will be 4 boxes above the 0.2. So there you are, there you have 0.24. So 1, 2, 3, 4, and we complete the histogram like this. A group of 50 adults who also estimated the mass M of the sweets in the jar. The histogram below shows information about their estimates. Use the histogram to make 2 comparisons between the distributions of the estimates of the students and the adults. So first of all, you can say that the minimum value for estimates by the adults was higher than that of the students. And in general, the adults tended to estimate higher values of the mass than the students. So this is one observation that we can make. So adults generally estimated higher values. And another interesting observation to make here is that there was less variation among the adults, because you can see here that most of them are between 200 and 500, as opposed to the children who had a significant portion between 0 and 200 as well. So we can tell that for the adults, there was smaller variation in the estimates. So smaller variation in the estimates of the adults. Now let's check the marking scheme. So, excuse me, the heights were supposed to be 0.09, 0.36, and 0.24. This is correct. In B, students have a greater range of estimates, which is the same as saying adults have a smaller variation in estimates. And on average, adults estimated a greater mass. So this seems to be correct. Let's move on. The table shows the times T minutes taken by 200 students to complete an IGCSE paper. On the grid, draw a histogram to show the information in the table. This is the very basic graphing problem in histograms. All you have to do is, again, estimate the width, estimate the height, and you can go ahead and start graphing. So the width here is going to be 20, 10, 5, and 15. This is our width. Now, frequency is the area. We want to get the height, so we have to divide the area by the width. So the height here is 0.5. The height here is 5. The height here is 16. And finally, the height at the end is 4. So now that we have the heights, we can easily draw the histogram. So from 40 to 60, we have a height of 0.5. You have to figure out the units in terms of the boxes to units. So here we have 2 units, and we have 5 boxes. So we want to get the value of one small box. So 5 boxes to 2 units. One box will be 0.4 units. 2 divided by 5, which is 0.4 units. So we want 0.5. So this is roughly one box or slightly greater than one box above. So we're going to draw the first histogram as such. Almost on the first box, because the first box is 0.4 and the second is 0.8, and we want 0.5. So it's much closer to the first box than the second box. Now for the second interval, which is from 60 to 70, we want a height of 5. So 5 is midway between 4 and 6. This is 5 here. So we rise up to a height of 5. So we rise up to this height here. And we draw the second interval, so till 70. There we are. And then for the next interval, we have a height of 16. So we go all the way up to this point here. There should be no spacing between the bars, of course. And then this ends at 75. So it ends halfway through. 1, 2, 3, 4, 5. It ends here. And we draw our vertical line. Finally, the last box goes from 75 to 90, and it is at 4. So we have this box here, and we're done. Unfortunately, the marking scheme here does not really provide the answer. It just says correct histogram, but judging by the previous questions, we seem to be on the right track here. This is how you would do it. The 200 students also estimate the total area A of the windows in the classroom. The results are shown in the table. Complete the histogram. So again, we have to start by estimating the width. So the width here is 40, and the width here is 40 as well. Here it's 50, and here it's 100. These are the widths. And then we realize that the frequency is the value of A. So to get the height, we divide A by W, area over width. So 32 over 40 will be 0.8. 64 over 40 will be 1.6. 80 over 50 will be 1.6 as well. 24 over 100 would be 0.24. Now, what is the actual height of the drawn bar? So we have to figure out the ratio between the boxes and the units. So here we have 5 boxes and 1 unit. So B to U, in a sense, 5 to 1. So one box is 0.2 units. So for example, this will be 0.2, and this here will be 0.4. So we want to get the height of this guy. So it's very likely to be the value that we got, which is 0.24, because it's much closer to the 0.2 than it is to the 0.4. So now we are confident that our values of h are the ones that should be drawn without any extra multiplication or anything. So from 20 to 60, so for the interval from 20 to 60, we want to draw 0.8. So first, let's get the ratio of boxes to units on the x-axis. So we have 5 boxes and 50 units. So one box is 5 units. So this here will be, excuse me, one box is 10 units, of course. I'm dividing by 5. So this here will be 10, 20, and so on. We want to go from 20 to 60. So we start at 20 and we go up to 0.8. 0.8 will be one box below the one. And we end it at 60 here. So this is our first bar. And then for the second bar, it goes from 60 to 100 at a height of 1.6. So 1.6 will be right here. And we go up to 1.6 here. And then we end it at 100. So we draw our second bar like this. And then for the third one, we have 100 to 150 at the height of 1.6 as well. So no problems there. We have another bar like this. And that concludes the problem. Again, there is no means of checking, but it seems to be the correct pattern. 200 students estimate the capacity X of a cup. The results are shown in the frequency table. Complete the histogram. It's the same idea again. You have a width of 100 here, 50, 50 again, 50 again, and finally 150. This is the width, and the frequency is the area, of course. So the height will be area over width. So 20 divided by 100 is 0.2. 55 will be 1.1. 55 divided by 50, I mean. 66 divided by 50 is going to be 1.32. $35 divided by 50 is going to be 0.7. And 24 divided by 150 is going to give us 0.16. Now that we have our proposed heights, these are our version of the height, we need to compare to their version of the height to make sure that the ratio is the same. Of course, we have to first figure out the ratio of boxes to units again. So from here to here, we have 10 boxes and 0.5 units. So one box will be 0.05 units. So for the height of the 100 to 150 bar, we are 2 units above the 1. So it's 1 plus 2 times 0.05, which is 0.1. So this gives us 1.1, and this is matching with our version. So all the other numbers should match as well. So for the first one, we have from 0 to 100, a height of 0.2. So 0.2 will be 4 boxes up because each box is 0.05. So this is the 0.2 here. And we can create our first block. And then they drew from 100 to 150. And then we have to draw 1.32. So again, each box is 0.05. We want to figure out where the 1.32 is. So this is 1.1, 1.2, 1.3. So 1.35 is here. So this here is 1.3, and this is 1.35. So 1.32 should be somewhere in the middle between them. And it goes from 150 to 200. So I'm just going to erase this bar here, midway between 1.3 and 1.35, and then I'm going to draw the line to 200, and I'm going to then bring it vertically down like this. This is the correct bar. And then we have 0.7 from 200 to 250. So 0.7 will be 4 boxes above the 0.5. So this here would be 0.7. And we go from 200 to 250. So 250 will be midway between 200 and 300. So this is 250 here. So 250 with 0.7 should be this point here. And we close the bar as well. And then from 250 to 400, we have a height of 0.16. So 0.16 would be between 0.1 and 0.2. So roughly at this box here, because this box is actually 0.15. So we can't get any more accurate than that. We're just going to complete the line here at 0.15 and just call it a day, because it's between 0.15 and 0.2. 0.16 is much closer to 0.15. So this should work as a proper histogram. Just let me redraw it more nicely. There it is. This is a nicer version than the blue one. And this concludes this problem. Again, they just tell us fully correct histogram. The 200 students record the time, T minutes, for their journey from school to home. The frequency table shows the results. On the grid, complete the histogram to show the information in the frequency table. So in the frequency table, we have a width of 10, and then 5, and then 5, and then 10, and then 30. Now, the frequency, like we said before, is the area. This is the width. We want to get the height. So 48 divided by 10 is 4.8. 48 divided by 5 will be 9.6. 60 divided by 5 is 12. This is 2.6. 18 divided by 30 is 0.6. They gave us the height of the first one, and it seems to be equivalent to our number because it's one box below 5. Let me do it more carefully so that you don't get lost. So the idea is that one unit, is equivalent to 5 boxes. So one box is 0.2 units. So the height of this bar is in fact 4.8, which matches our value. So we can just use the rest of our values as estimates. Now, we want to draw from 10 to 15, a height of 9.6. So 9.6 would be 3 boxes above the 9. So there it is. And we want to go from 10 to 15. So 1, 2, 3, just midway between 10 and 20, because let me just get you the ratio as well here. So from 10 to 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 boxes for 10 units. So one box for 1 unit. And we want to go to 15. So we need to count 5 boxes. So I'm just going to count here 1, 2, 3, 4, 5. These are my 5 boxes. And I'm going to bring it down like this. And like that as well. Of course, using the ruler, you can draw a much nicer and more accurate line. This is just to give you a general idea of the concept. So after the 9.6, we have 15 to 20, and it goes up to 12. This is quite simple to sketch because you just go up to the top and you reach 12, and then you just plot this bar like this from 15 to 20. Then from 20 to 30, we have a height of 2.6. So 2.6 will be 3 units above the 2. So there is our 2.6. There it is. And we go from 20 to 30. So all the way to 30 like this. And we bring down our bar. Finally, from 30 to 60, we have a height of 0.6. So 0.6 will be the third box up, will be right here. And we take it all the way to the 60. We have a very wide bar like this. And this concludes, again, our version of the histogram. So this is another problem here. We have 200 people running 10 kilometers, and we have a table. So it's the same procedure pretty much. We have a width of 10, width of 5, 5, 5, and 5. And then finally, we have a width of 20. We have the area here. So 8 divided by 10 is 0.8. 22 divided by 5 will be 4.4. 95 divided by 5 is 19. 55 divided by 5 is 11. And 14 divided by 5 will be 2.8. Finally, 6 divided by 20 is 0.3. These are the heights. Now let's test against their height. So let's construct the ratios first. I'm just going to automatically create ratios for the vertical and the horizontal to get it over with. So for the vertical, we have 2 units and we have 5 boxes. So one box is equivalent to 2 divided by 5, which is 0.4 units. And then for the horizontal, we have 10 boxes and 10 units. So it seems that one box is just equivalent to 1 unit. Now, from 40 to 45, we are one box above the 4. So one box is 0.4. So this is 4.4. 4 plus 0.4. So this seems to be equivalent to the number that we have in the table, which is 4.4 as well. So all the rest of our numbers are correct, which tells us that this here is going to be 1.6, for example. And then if you want 0.8, we just have to go 2 boxes up. This is 0.8 here. So from 30 to 40, we have 0.8. So we can just draw this histogram here. And then from 45 to 50, we want to go all the way up to 19. 19 will be halfway between 20 and 18. So this is, or not quite, excuse me. So we have 1, 2, 3, 4, 5. So 18.4, 18.8, 19.2, 19.6, and 20. So it's not exactly correct. It's supposed to be halfway between the 2 boxes. This is the more accurate estimation. And we go from 45 to 50. So at the 50, I'm just going to plot a point here. And at the 45 as well. And this is my new histogram or my new bar. And then for the following one, from 50 to 55, we want to be at 11. So again, 11 will be halfway between 10 and 12. So midway through between box 2 and box 3. And we move 5 boxes to the right. So 1, 2, 3, 4, 5. So something like this. From 50 to 55. Forgive me for the roughness of the drawing, but because I'm unable to use a ruler, but in the exam, you have access to a ruler, so you should be able to draw it much more accurately than I do. And then from 55 to 60, we want to have a height of 2.8. So 2.8 would be 2 boxes above the 2. and this goes from 55 to 60. So there we go. From 55 to 60 is 2 boxes above the 2. And then from 60 to 80, it's 0.3. So 0.3 is actually less than the first box because the first box is worth 0.4. So it's a very small bar here, almost on the first box, but that's it. And again, we don't have access to the answer, unfortunately. For the final question in this video, we are told there are 100 students in group B. The teacher records the distance d meters each of these students runs in 1 minute. The results are shown in the frequency table. Complete the histogram to show the information in the frequency table. So again, we have to calculate the width first. 100, 50, 30, and then 40. Finally, 80. Now that we have our width, we want to get the height. So we divide the area by the width. The number of students is the area because this is the frequency. 20 divided by 100 is 0.2. 22 divided by 50 would be 0.44. And then 30 divided by 30 is just 1. 16 divided by 40 would be 0.4. And finally, 12 divided by 80 gives us, excuse me, so 12 divided by 80, yes, this gives us 0.15. We want to test against their first height, and here the first height is very clear and very obvious. It is 0.2. So we know that our values are correct. Now for the second block, you want a height of 0.44. So you need to get the ratio between units and blocks as we normally do. So for the vertical here, we have 5 boxes and 0.2 units. So one box will be 0.2 divided by 5, which is 0.04 units. So 0.44 would be one box above the 0.4. We just go up to here. And then we want to go from 200 to 250. This is quite obvious here. It's just the middle between 200 and 300. So you can close it up like this. This is 250. For the sake of thoroughness, we are going to calculate the ratio here as well. So from 200 to 250, we have 50 units and we have 10 boxes. So here we have 10 boxes and 50 units. So one box is equal to 5 units. So we want to go from 250 to 280. So 280 would be 6 boxes after the 250. 1, 2, 3, 4, 5, 6. So there is the 280. Now, the height here is 1 exactly. So 1 means that we just go all the way up to here. So we can just draw the histogram like this. Might be slightly inaccurate. Let me do this again. There it is. Now, for the next bar, we have a height of 0.4, and it goes from 280 to 320. So to go to 320, first let's count the boxes on the x-axis. We said that one box is 5 units, so 305, 310, 15, and 20. So there is our 320. And we want to go to a height of 0.4 exactly. So 0.4 is one of the big blocks here, so it's easy to spot. There it is. I just made a mistake here, I'm sorry. It just goes to the first box, not the second box. There we go. So this is 0.4. And finally, we want to get 0.15. So this is not very clear. However, we can calculate it. We said that for the vertical, each small box is worth 0.04 units. So this is 0.04, 0.08, 0.12, 0.16. So this is 0.16, and we want 0.15. So we're just going to use 0.16 because that's the best we can do within the given accuracy. So one box below the 0.2 or 4 boxes above the x-axis. So 1, 2, 3, 4. And we draw the remaining histogram. There we are. And this is the final bar that we need to draw. So this is the end of our video. I hope this has been beneficial. Thank you for watching.